Hi, good day, my friends. This is Nathan here, and I'm a software engineer in Melbourne. Today, I'm going to talk about interaction to next append, which will replace first input delay as the next core value in 2024. For those of you who doesn't know, web core values are standards that Google uses to evaluate your website performance, and the result will impact your search engine ranking directly. So I think it's a good time to understand page interactions and what causes bad INP and what's our solutions. The video gonna be relatively long today, and I will introduce what is INP, how can we test our page interactions, event loop foundations that help us to understand INP from a lower level, and at last, what causes bad INP and what's our suggested solution to fix bad INP. INP means from user started an action from the web page till you see the next append to happen. In between the time is INP. So what is good INP? Less than 200 milliseconds. That's good. Between 200 to 500 milliseconds, that's something you need to improve. And if it's greater than 500 milliseconds, that's poor INP result. Cool. How do we identify those INP issues? A good way is by install Chrome core value extensions. With that, you can see largest contentful pane, the cumulative layout shift, first input delay, and interaction to next append, and corresponding values for the page. Make sure in the setting you check console logging. So per each user interaction, and you will see the corresponding interaction and test values, which is pretty handy. But for most of our browser, we need to understand the user are not using high performance machine, and to simulating those kind of result, we need to add a throttling by, say, setting your CPU to 4 times slower and the network as fast as 3G, and that will bring out a lot of problems you didn't see. If you find any suspicious value, say really large INP number, you can go to your performance and do the recording. And by looking into the details and break down into the tasks, then that will help you on debugging and identify which function caused the problem. But before I move on, I would like to pull everyone out of the topic and discuss a bit about what is event loop. Event loop is a mechanism that oversees 3 stacks. They are macro task queue, or you can call it task queue in short, core stack, and also micro task queue. So you can imagine there's a restaurant and there's only one working hand, which is event loop. It's taking orders from customers, which are web APIs, also JavaScript execution itself. And each order is like one line or one method of JavaScript. And they will be moved to the core stack first. You can imagine that's a kitchen, and they'll be cooked there. Event loop will run those tasks from the oldest to the newest. And once that's run, you can imagine that's cooked. It will be served by event loop, and it will be removed from the core stack later on. And for those tasks which are not ready yet, event loop will pass that to a helping hand. You can imagine that's C++ for Node Engine or web APIs for the browser, and they will be made ready before they are returned to the event loop. But instead of going back to the core stack or going to the micro task queue, it will be put into a higher priority place, which is micro task queue. and that's when all the like a promise callback executed. Cool. I'll use two examples. Hope that can help us understand the event loop mechanism better. The first one is recursion. So if we are doing adding from 1 to n, there are two ways. Either we are doing that by for loop, or we can run this in the recursion. If we do that in recursion, we'll keep calling the recursion function by itself and until we had a total number. If we are passing a really large n number, for example 400,000, and what happens in the call stack is it will be flattened and it will be spiked. It will cause maximum call stack size exceeded. This is one quality of a JavaScript engine, and we need to keep in mind when we are using recursion. Just use that with careful. The second example are 3 lines of code, and the first one is set timeout console log. This is from set timeout, and the second line is promise.then, and this is from a promise that will go into micro task queue. And the third line would be, this is from main thread. I'll pause for 5 seconds. Let's think about what would be the result that prints out on the screen. Cool. I'll release the answer now. The first line would be, this is from the main thread, then the promise, then set timeout, and I'll explain why line by line. So step 1, the call stack is empty, and the task queue received 3 lines of JavaScript code, and correspondingly that will be 3 tasks. And event loop will move those 3 tasks to call stack and execute them one by one. And the first one will be run, which is set timeout. Event loop will pass set timeout to timer API, and timer API see the timeout is 0. It will immediately put the corresponding callback, which is console log. This is from set timeout in the task queue again, and that will be executed in the next loop. Now the event loop will keep running. That's when you see a promise will be executed. Because the promise is resolved, it will put the corresponding chained callback, which is in the then method, to the micro task queue, and the event loop will keep running. That's when you see the loop is executing console log. This is from main thread and is printed out first. Then before the event loop finish the current loop, it will check the micro task queue as always, because there's a callback function that to be run, which is this is from a promise, so that will be printed out second, and then that will be removed as well. And at last, the event loop will move this is from set timeout to call stack and execute that in the next loop. That's when you see the third line, and this is from set timeout. The reason I spent some time to explain the event loop is to help us understand what exactly could cause the block. As JavaScript is single-threaded, it has to block when it's running a method in the call stack. And if it's high cost, it will cause the loop to block. As a result, all other tasks will be delayed. Then it could help us to understand long task better. Long task is one of the main reasons for INP delays. If a task is cost more than 50 milliseconds, it can be defined as a long task. Basically, it means the loop is blocked. The UI is frozen and other tasks will need to wait. All the INP issues caused by JavaScript execution itself are rooted from long tasks. And they are falling into the following scenarios. Number one, complex computing. And this is definitely a high cost, and it will inevitably block the loop. The second one would be fetch data. Fetch data is also costly, but the delay is mainly caused by network communication. If we can have a fallback or loading effect, that could reduce the INP value to minimum. Let's go back to the definition. So what INP means, from user interaction start to you see the next append to happen, what's in between the time is INP. So if user clicks a button and that fires an AJAX call, in between we are loading a loading effect rather than wait for a response. And say the time triggered for the loading effect to render is 26 milliseconds, then the INP will be 26 milliseconds. If we don't have a loading effect, say the network call costs like 1 second, then the INP will be huge, will be same as 1 second. Hope that makes sense. So cool. With the React suspense, it will be quite handy to do this kind of fallback with the loading effect. Suspense is supported even before React 18, and so definitely you can use it. The next consideration would be recursion or long loops. We've already covered that we should not use recursion in JavaScript, but for long loops, I know you might argue, hey, why don't we use pagination to avoid long loops? But if you have to, there is an option to reduce INP even with the long loop. You know, for React 18, there's a new feature called use transition, and we can take the advantage of it. It will provide is pending status. So basically it tells the UI if it's ready or not. If the long task is still going, the is pending will be true, otherwise it will be false. So by utilizing the is pending states, we can have loading effect. When it's expanding, we load the fallback, otherwise we will load the result UI. And as a result, we can bring down the INP value to minimum. Because the fallback is happening immediately. The next one is a large file reading. Definitely that's high cost. And also third-party scripts, that's also risky. So we need to be aware. Another main consideration that will also cause bad INP, that's when the page doing painting. Number one would be forced synchronized layout. In JavaScript, if we are setting a layout attribute like width, offset width, and immediately we will read that will stop the UI by doing calculation. If we are doing another setting afterwards, it will be super inefficient. So it is suggested to have all the resets going in bash, but have the reading afterwards. And the next one would be expensive CSS selectors. For example, if you are using root level CSS selectors, that'll be costly as well. And also for high cost animations, like a constant repaint by doing transition, because we are changing the width constantly, so that'll be a cost. So if you if you find the INP value is high against this kind of animation, and just keep that in mind. Probably you didn't write your CSS properly. And the next one would be constantly repaint. That's similar. Yeah, say if we are doing a blink animation like this infinitely, that'll be a cost. And at last, single and large CSS file. That's not recommended. I don't believe many websites is doing that. After HTTP2 has been introduced, it is encouraged to split your bundle file in multiple. And the last reason could be memory leak, but that will be out of the topic for this video. To sum up, Google introduces INP as the next core value will bring the front-end quality to a new level. It is some good news for the front-end developers who cares not just getting the UI meets the design, but also every details of the performance. Front-end is traffic. Front-end is gold. It's never a place you Google for some CSS solutions, then you can get the UI down and find a job. It will eventually meet all other engineer studies at the same place. That's the computer science itself.